Morning, everyone. Great crowd. So, thank you for showing up. It was an embargoed session, so not very many people knew about this session till early on. So, thanks for showing up. My name is Ganesh Srinivasan. I'm a PM in the Azure networking team. Really excited to be here. This is a very exciting topic for us, and I'm going to be joined by Shkumbin from Nokia and Scott from Atabotics today. We have a lot to cover, a lot to cover. And we'll make it as exciting as possible because we've got some very cool demos set up here. A lot of you may be curious as to what this is. You're going to see this in action. You'll hear about what this is later in this session. I have HoloLenses, so stick around, and we'll make it as exciting as possible. So, I'm not going to be announcing a product or talking about something that's available today. I'm talking about the journey we are on, and I'm going to announce a technical preview of our edge compute offering along with private cellular connectivity. That's what this talk is going to be about. You're not going to see timelines or releases of features that are available, but you'll understand where we are headed around use cases and concepts for MEC and private cellular connectivity. So with that, how many of you have not heard about 5G? I don't think there's anyone in this room who's not heard about 5G. And a lot of use cases get thrown around, and people say, build it and they will come because they have to justify the infrastructure investments. I hear, every time we talk about 5G, I hear about, Apple introducing the iPhone in 2007. So we get to hear a lot about that. So we've spent about almost a year thinking about what 5G means to Microsoft. The use cases that people talk about in terms of 5G are essentially lower latency, significantly lower latency, and significantly higher bit rates or throughput that you would experience in a network. And you can only achieve lower latencies and higher throughput if you move the workloads that these applications that run on phones or any kind of devices move closer to the user, which necessitates the need for edge compute. And when you talk about 10 gigabits per second and crazy bit rates and 1 to 5 millisecond round trip latencies, they are for not the consumer scenarios that we all use our cell phones for. They are for really mission critical immersive applications, which means most of the deployments from 5G that will be happening down the road are going to be private cellular deployments. They're not going to be commercial cellular deployments that are going to offer you the kind of latencies and throughput that they are talking about these days. So that's got us thinking about what we should be doing. We have had the intelligent cloud or Azure cloud for over 10 years now. We've been working hard with a lot of customers to move them from on-premises to the cloud. You're going to see the opposite journey happen right now, right? Critical workloads will start moving back on-premises, but you want all the characteristics of the cloud, and that's what we're going to talk about. And one size does not fit all was what we thought. So we have two versions of edge compute that I'm going to be talking about. One is called MEC, and the other is called NEC. I'll get into what these two are. So as I said a few minutes back, over the past decade, most of us in Azure have been spending time building features and capabilities in the platform to enable people to lift and shift applications from their premises to the cloud. And with lower latency, higher throughput technologies like 5G, we are going to start seeing the reverse trend happen, which means workloads are going to be starting to move back to the premises or somewhere in between the premises and the cloud to achieve all these better performance characteristics that their workloads need. So what we are actually looking to do is put compute at the edge of our networks, be it our network or at the edge of a telco network. That's one scenario that could benefit a lot of use cases where game developers or application developers who want to serve content to a lot of customers want to actually place their workloads on. So that's what we call network edge compute. Back in March in Mobile World Congress, we announced a partnership with AT&T where we're doing network edge compute. I'm going to be talking about what we've built with AT&T and what's available today and what journey or what direction we are headed there. And then, if you listen to Satya and all the keynotes and all the major sessions that we've had so far, the theme hybrid, Azure Arc, and a lot of other topics keep coming up over and over again. And Azure Stack Edge was one of these products where we announced exciting SKUs with GPUs, ruggedized SKUs that were really tiny with battery packs attached to them. So we decided we would build a smaller edge compute platform based on the Azure Stack Edge platform. That's what we refer to as multi-access edge compute. And on this multi-access edge compute, what we've done as the networking team here is we built the ability to run a managed mobile network, be it 4G or 5G, and consume it as a service. So I'm going to talk about use cases that put edge compute and connectivity together, and show you a few demonstrations on what that means. So as I mentioned, applications are moving back to the premises from the cloud, but people have invested a lot of time and resources in building tools and building methodologies and processes to adopt the cloud. So what we are actually working on is giving customers the capability to consume on-prem compute capabilities as though they were running in the cloud. So you can use the same set of tools you use to manage your infrastructure. You can use the same set of tools to author your software, or use the same CI/CD pipelines to deploy applications. And by the fact that you're just one hop away from the end user, you're going to get amazing performance. So this is a lot of people talk about CI/CD and how efficient it is and all that, and if you move something back to your premises, it's going to be extremely hard. So we want you and the developers to keep using what they're used to, which is Visual Studio Code, using Azure DevOps, using GitHub to store code. You just do deployments. It's just that you won't know the difference whether you're deploying into an Azure region or into an edge compute platform that we're running on-prem. So that's one of the key value props that we want to offer the end customer. The other thing is, of course, is the fact that, I missed a slide. No worries. You can manage on-premises infrastructure, be it the MEC or the NEC, which I'll talk about in a minute, the same way you manage any resources on Azure, just the way you manage virtual machines in Azure. So you're going to get the same manageability experience. So what is MEC and what is NEC? MEC is, in our terms, multi-access edge compute. It's based on the Azure Stack Edge platform. It's a one new device that you get today. There are other form factors that are coming out there. We've added the ability to run managed networks as a service on top of that. So you will see examples, or in this particular case here, this is actually the Azure Stack Edge device itself. And we have workloads and applications running in here. You're going to see a few demonstrations of that. We will show how a managed mobile network runs on top of that. That's a significant value. So when you put the network and the compute right next to each other, you're going to see new scenarios come up, new use cases come up that couldn't have been done in the past without these capabilities. Now, network edge compute, on the other hand, as I mentioned earlier, is something we've been working in partnership with a lot of telcos. We've essentially announced this with AT&T back in March, where we actually placed our Azure compute one hop away from their 5G core. The first site went live in Dallas a few weeks back, and we have some workloads running on them already that I'm going to show you in a few minutes. So as I mentioned, our NEC offering is primarily targeted for the edge of our cloud and one hop away from in the telco's infrastructure. This is a larger scale. It's optimized for multi-tenant workloads, so any developer can deploy workloads into them just like how they would deploy into any Azure region. On the other hand, MEC is where you actually deploy boxes in your premises, you wire them up to your networks, and we run workloads on them. So MEC is not something new. MEC has been around for years now. Telcos have been using this term and have been building applications just to run their networks on these boxes. Now, what good is a network? And we, on the other hand, have been spending a lot of time building edge compute in various forms, but it just runs the applications. Running them side by side is going to add a lot of complexities, and when you start putting them together is when a lot of cool things start happening. You start seeing new scenarios and new workloads happen, and it reduces the overhead of manageability and resources on premises too. So what we've done is essentially taken the best of both. We've worked with a huge partner ecosystem, and we've built the ability to run a managed network on the box itself. So it takes a village to build a mobile network, and that's why you don't see very many people building these networks the way they build Wi-Fi networks. So we've actually partnered with various ISVs and various SIs across various segments, and we actually got to build an integrated solution where you can drag and drop and actually compose a private cellular network, right? So if you want SIM cards, you could go to one of our SIM vendors, drag and drop, and have how many ever SIM cards you want built. We can run a managed packet core as a service on this edge compute box. We can have radios that are connected and managed from our platform, and all these will be integrated with the other Azure services. So we worked very closely with several ISVs to have them onboarded onto the platform, and we've worked with a bunch of SIs. Setting these up is not for the faint-hearted. So we want you to consume it as a service, and that's where a lot of SIs come in. These SIs effectively act as solutions integrators. They put things together and run it as a managed service for you. So that's the platform we have, and over the course of the next few minutes, you're going to see various demonstrations and use cases of how MEC and NEC come together. And before I get into use cases, I wanted to show what a full-fledged solution could look like. So I actually want to invite Shkumbin from Nokia to talk about the Nokia DAC product.
Hear me? Okay, now you can hear me. Thanks, Ganesh, for inviting me here. I'm really excited to be here and share with you some of the progress we have made together with Ganesh and the team. But before going there, I have to say that since our first meeting with Ganesh, I was absolutely delighted to see that we share a common vision on how do we enable enterprises in helping them through their digital transformation journey. As Ganesh mentioned, the need for high-speed, low-latency, mission-critical networking cannot be fulfilled by the general-purpose cellular networks out there. Wi-Fi often fails, both in terms of capacity, coverage, and reliability in harsh environments. So in that context, a need for enterprises to deploy private networks are essential. There are specifically, okay, it's this one, specifically 4 elements that we address with respect to enterprises. Number 1, enterprises need a simple way to deploy and manage private networks. You cannot expect enterprises to become experts in cellular networking. As you said, it's not for the faint-hearted. Second, there is a growing need in various verticals in the industries to manage the data flow properly. For some verticals, actually managing the data flow and keeping them within their IT systems is an absolute needed feature. Third, many of the enterprises, while they operate in multiple sites, they often operate across boundaries of a country or even continents. We need to offer a simple management tool that an individual can manage a mission-critical network, say from Sao Paulo all the way to Cape Town, Singapore, or Manila, or all at the same time. And fourth, and perhaps the most important one, for many of these enterprises, connectivity is just the basics. They need ways to connect that to their business processes and technologies. At Nokia, we have been working in addressing exactly these needs, and our solution that we call Digital Automation Cloud is essentially built with enterprises from ground up and focused on the needs that I addressed there earlier. Our implementation consists of what we call Nokia Digital Automation Regional Cloud, which is in essence a management center which is managing tens of thousands of private networks globally. On the customer side, the customer gets edge compute. In this particular case, we run our Nokia Digital Automation Cloud software on top of Azure Stack Edge. In addition to that, the customers need some radio, which can range from a pico radio all the way to the macro radios that the CSPs use around the world. What we have done here is that we have actually set up a private LTE network, and that's operational here. We were setting it up. It takes about 10 minutes to set it up. We set it up prior to the session so that we can save some time. And I'll show you here in an instance, the view where you can see the network up and running. We have one radio up. We have several networks running. Actually, as we speak here, there is one here, which is in Microsoft Ignite. And we have 3 devices connected. You can manage SIMs one way or another, provision, deprovision, and so on. But what do we use this network for? So let me take an example here. So I have here a ruggedized terminal where we have put our own SIM cards that operates in this private network here. Implements a group communication solution, which is typical for various industries, where you can call someone to do some task. So in this particular case, I can call our CTO, Janne. Janne, where are you? Okay, so why don't you come and do something useful? So what we have here is actually a screwdriver, and I'll ask Janne to screw a few screws on this plate here. This is not an ordinary screwdriver. Well, it screws stuff. So Janne, this is yours. But it's actually connected to the private network that we have done. We have created here. And what that private network enables is that the parameters which are needed to do the job correctly are downloaded on the screwdriver within the private network and monitors that the job is done properly. So here, if you screw something up correctly, we can see very soon in a few seconds.
This was correct one.
There. So now we see it's OK. So now as Janne is our CTO, not very good with hardware, I'm pretty sure he's not going to do a good job in the next one. As I told you, predictable. So these kind of enablers are possible with a high quality, highly secure network. This is just a glimpse of, if you can go back to these slides. So this is just a glimpse of what you can get when you merge the best of both worlds. Best of cloud solutions coming through Azure and the full range of Azure products and services, and the communication connectivity technologies coming from a company such as Nokia. It enables seamless management of flow of data. Data stays wherever you want to be, and of course ensures that your investments are really efficient. Thank you, Ganesh.
Thank you, Shkumbin. So that was one example of how an end-to-end solution worked on private LTE. Now, we're actually going to talk about a lot more scenarios. So the first use case being how robotics can be applied to supply chain management. So I'd like to invite Scott from Autobotics to come on stage and talk to us about how robotics can solve problems and how edge compute and private cellular connectivity can help their use case.
Ganesh, thank you. Just like a screwdriver, just slightly more complicated. We started looking at modern supply chain, and we're inspired by natural systems. We moved away from the two-dimensional distribution of people walking aisles and started to think about a robot in the same way an ant builds a colony. We have the highest density storage solution that uses 3D robotics. Now, we didn't bring the monkey bars with you for the robot today, but our robots move through a big metal cage. So you can imagine that that's a challenge from the communication point of view. So in doing this, we started creating very small solutions, 1,000 bins, up to right now North America's largest automated supply chain solution, which is 194,000 bins. We route these robots in 3 dimensions through these structures. So that has led now to the idea of a distributed network of warehouse automation. With our partnership with Microsoft, we see this being a completely cloud-enabled experience and managing now this network and the load balancing through it. Now, we're currently using DataBox Edge, Azure Sphere, over private LTE in a fleet of robots in our R&D group right now. And The goal in this is to move away from the 900 megahertz radio system that originally brought us to market. Now, limited packet sizes combined with data latency didn't allow us to scale to the size of the solutions the market's asking us to do. It also means that we can move away from on-prem data redundancy and security. By linking this now through DataBox Edge and Azure, we don't have to provide the infrastructure you typically see in large server racks running our SQL database systems. So right now, Sunny, our head roboticist, is running this robot. This is like a turtle on a fence post right now. He thinks he's the robot in that simulation. He's going away, putting bins away right now, picking bins and moving through this. But we are communicating to this robot over the private cellular network through the encrypted Azure Sphere. So we have data security in the communication, but we're also taking real-time telemetry out of the robot, which is something we couldn't do before. We're using this now to diagnose issues in the robots, performance in the system, making sure that the servo drives and all the mechatronics are functioning the way we expect them to. This allows us now to use the cloud tools that Microsoft has enabled to do now predictive maintenance analytics and provide data transparency through IoT Central, both to our NOC back in Calgary, Alberta, as well as provide that information to our customers that use our technology. So they have a real-time, transparent look at the performance of their systems, all now fed through this ecosystem. So Sphere, Private LTE, DataBox Edge, IoT Central is what we're now functioning with in this solution. I think that's what we have for you, right, Ganesh?
Thank you,
Excellent.
Scott.
Thank you, sir. We'll let Sunny put the robot to sleep now.
So, Adabotics here is a classic example of how various components from Microsoft and various solutions from our partners came together to build an end-to-end solution. So we have access points here. So the actual network that controls here actually runs here. This is a Ruckus access point that runs CBRS. So we're operating in the 3.5 gigahertz spectrum. We have a packet core from Metaswitch that's running here. And the control software for the robot also runs here. So the end-to-end solution is all on stage here right now. You can see me wearing a HoloLens, so you can guess what's next in the list. So I'm going to talk about a scenario where edge compute and private connectivity can help with mixed reality scenarios. So in this particular case, I'm going to try, I'm new to HoloLens, so please bear with me. I'm going to try servicing an airplane landing gear. Okay? There's nothing here. I'm going to simulate it and I'm going to show you how it works. So this is to make sure that you can see what I can see, hopefully. I placed the landing gear somewhere. It's behind Anavi. So I'm going to walk here. If you can see the screen and if you can see what I can see, there's going to be a few seconds lag. Or I'm going to carry it with me and I'm going to place it here. So you're actually going to see a virtual image of a landing gear right in front of me. Can you all see the landing gear? So what we're going to do is check if everything's functional, whether the tire pressure is fine. And for someone who's not skilled with actually doing something, we are actually going to help them, figure out how to troubleshoot them. So there should be a menu somewhere around me, which I have to search now. The menu is here. Oh. I'm sorry for the. I found it. This is the problem where something spatial. And you can see more of these. So I'm going to launch a fresh instance of this. The hard part now, just typing. So what I'm doing is I'm using a software called Manifest, which is made by a company called Tactile. This is completely containerized and runs on edge compute. Now I'm going to look for the airplane landing gear model, which is what I'm doing right now. So you see tons of these landing gear models. I'm going to pin the menu here so I don't have to go on a wild goose chase if it disappears. So we do have this landing gear, and I'm actually going to place this landing gear right in front of us. So what it's doing right now is rendering the gear. So while it's rendering, what I'm going to do is I'm going to open the template, and I'm going to say, okay, what do I need to do to inspect the landing gear? So it goes, and you can see the landing gear showed up in front of me. So I'm going to do a few operations to demonstrate how the landing gear inspection happens. The key thing I want you to take away from this is that this whole operation runs on edge compute. Oh. I'm sorry, I've had a little bit of trouble with this, but I think you get the picture of the fact that because of low latency, rendering and serving the content becomes a lot easier. So you can actually do a lot of stuff more efficiently. You can place all these things in the facility itself where you want to do this. So with private LTE and edge compute, this is going to be an awesome scenario. Thank you, Hanavi. I'm going to try something trickier right now. With a friendly audience like this, that's not a problem. The next scenario that I actually want to show is gaming. So what I'm going to be doing is I have a few of my teammates sitting in the front row who are actually going to be playing a video game with me. This video game is actually hosted in our NEC platform in AT&T Dallas. Okay, you can all see my phone. I'm going to play this game called Tap and Field. So you just tap and it's going to run. So I'm going to join the next race as Sarah. And you see the other players pop up. Those are the three other teammates sitting here. So it's going to wait for a few seconds for the next player to show up. We are all racing right now. We are all tapping.
Go, go.
Go, Sarah.
And if you see the background is, you can see AT&T and Microsoft's logos. So this scenario at scale means a lot of compute gets consumed, and this could only be possible by placing these game servers closer to the user. The control planes of the games can sit far away, but the game servers have to be placed close to the user. That okay, so going back to where we left off, we saw a demo of how edge compute could help mixed reality. We saw how edge compute and could help with gaming scenarios where games are actually hosted on our edge instance. The rest can run on the cloud. We're now going to talk about another scenario which is very important for public safety perspective. You see drones all over the place, and they're a nuisance to public safety. When you have huge events like the New York Marathon or the Boston Marathon or any place where a lot of people gather, tracking where the drones come from and making sure that the drones are shut off is very, very important because they could be an attack vector. So what this company does, company called Whirlpool does, is they actually have these sensors deployed all over the place, and they get data from these sensors into edge compute platforms to process the data, to identify the source of where the drone is being controlled from, so that that information can be fed into public safety to apprehend them. So this Whirlpool-based solution is one of the first solutions that we started working with in partnership with AT&T, and this solution runs on our NEC platform. I don't have drones here, so I'm unfortunately not going to be able to show you a live demo of a drone flying and us going and catching the drone operator, but the accuracy and efficiency has been incredible thanks to edge compute. So there's another application that, again, when we started looking at edge compute, everyone thinks about CDN as one of the first use cases, right? And CDN is not sexy because it's already edge compute, purpose-built edge compute. So the next thing that came to our mind was, what can we do with media streaming? So we partnered with an ISV called NetInsight, where this technology is pretty unique. If you're in a stadium watching a game and you want to have different views and you want to overlay statistics and things like that from your mobile phones, you could actually do that by running the entire transcoding and content delivery on the edge compute platform that we have. So we have working instances of NetInsight where if you're watching a Formula 1 game, for example, you could pick the different views. You can pick the paddocks views, you can pick the views in every corner, and also overlay the statistics, or even view the view that a driver, your favorite driver, actually has. So edge compute comes in to make all those things possible. Earlier this week, again, one of the other major announcements that we made was in agriculture, and automated intelligent agriculture. So we have this product called FarmBeats that we announced that basically brings in all our technologies, IoT and various sensors and TV white spaces and all communications as a managed service for the end customer. Now, we've been working with the FarmBeats team on a few pilots in farms where private LTE can be deployed, and all the intelligent sensors actually communicate with a box that's deployed in the farm that can make all these decisions. And earlier this week, we also announced ExpressRoute with satellite providers. So if the farm is in the middle of nowhere where we don't actually have terrestrial connectivity, we could actually connect from the farm back to the cloud through ExpressRoute for satellite connectivity. So it all brings the story together where we can do connectivity within the farm, edge compute, and connectivity from the farm back to the cloud. So this was just a glimpse of a few scenarios that could actually benefit from edge computing, right? If you're in the middle of a factory floor like this, getting Wi-Fi signals out for your devices is going to be a very, very hard problem to solve. No matter how many devices you throw at it, access points, you are going to have signal strength issues. And more importantly, you're going to get best effort service. So you can't run critical machinery on top of that. So that's where private LTE and private 5G technologies come in to solve the problem. Same thing goes with retail. Just like what you saw for supply chain, we are now, a lot of people talk about Amazon Go and technologies like that. We can now enable technologies like that where there are cameras looking at every rack, or robots moving around aisles scanning stuff, all those things are going to generate tons of data that needs to be processed locally. And you need secure communications between all these robots performing all these actions. So again, that's another very important use case for placing private mobile networks and edge compute as a service. So we talked about some use cases and scenarios. Now, what's the experience like to go from 0 to 100 and actually deploying a cellular network in the cloud, right? I'm going to show you what does it take to actually deploy the packet core that we talk about. I have a packet core from a company called Metaswitch, and I have their IMS core. IMS is the component that offers voice. So if you want to operate a full cellular network in the cloud or in the edge box like this, I wanted to show you what the experience would be like. So I'm going to actually start with nothing and deploy a packet core and show you what it takes. So this is a dashboard of the packet core. Right now, you have to look at the top left graph. It shows nothing running. This is actually the view of the 5G Fusion core that we are actually going to be deploying. People have talked about the fact that these packet cores and all these things are moving from physical appliances to VMs to containers. This is an instance where the actual packet core is built on Kubernetes. So I'm going to go into the Kubernetes dashboard, and I'm going to deploy the 5G packet core right now. So I'm going to go to the catalog, pick this. If you see, you'll see a very familiar YAML file, just like what you're used to with any deployment. So I just submitted the request to create a packet core. So it's going to take a few seconds, and you're going to see the packet core spinning up. And as the packet core is spinning up, you'll start seeing these containers start showing up and becoming active. And while we wait for this, we can start deploying the IMS core. So the IMS is the component that offers voice capabilities. So Skumbin demonstrated some voice capabilities. So if you wanted voice capabilities like that in your private mobile networks, you need an IMS core. So this deployment job went through. And within a few seconds, you started seeing all these containers get started. The next refresh of this dashboard is going to show you all the containers up and running. So once they reach a steady state, which is in about a minute, this packet core is fully functional. And if you actually connected these access points to that and started turning them on, you can actually have data communications out to the internet. And once the IMS core also comes up just like this, you can actually make phone calls end to end. I didn't want to do it on stage, but that's how easy it is to make a few clicks of your mouse and actually have a full-fledged mobile network with data and voice created right in front of you. So it's as simple as that, right? So you can see where we are headed. So we want to enable these technologies where you can consume these as services. Since these are containers, you can use your standard CI/CD tools, and you don't have to. Your appliance vendors can use these standard CI/CD tools, patch them, update them, keep them up to date, and make sure that your mobile network is always up and running. So time goes really fast. So in the last 40 minutes or so, you've seen a lot of use cases. You saw the use of an automated screwdriver, which is a demonstration of how industrial automation can benefit from edge compute and private cellular networks. We saw AR, VR using HoloLenses, where rendering happens on a private edge box, where you can actually do real things, where assisting operators who need specialized instructions. We saw a gaming platform, and we saw media streaming. We saw drone tracking, and last of all, we saw what we can do by deploying all these packet cores on a managed fashion in the cloud or in the edge box. So I guess that gives you a rough idea of where we are headed. Our goal is to kind of build a nice shrink-wrap product around all these things and make it simple for you to consume. This is a journey that we've just started, so you'll hear more about it from us in the near future on what what we're going to ship it as. So in the meantime, if this is interesting to you and this appeals to you, we would love to hear from you on the use cases that you could benefit from. And if you're interested in trials and pilots, we would be happy to work with you and bring in our partners to build pilots with you, learn jointly, and hopefully help you solve some of the problems that you've been having with all your automation. Thank you.